Okay, here's another nice question. Let me write the formula down again. So Mg3N2 as a solid reacts with water as a liquid to produce magnesium hydroxide, which is a solid, plus ammonia, NH3 gas. So they say if this portion is 81% efficient, what mass of ammonia can be prepared from 24.5 kilograms? So they talk about efficiency, and that would be like the percent yield. So percent yield is equal to experimental over stoichiometry calculated one, or theoretical times 100. So they're saying it's 81% efficient. So it's 81% yield is equal to, I guess I don't know either of those numbers. But I think with stoichiometry, I can figure out that number. So they're saying I'm starting with 24.5 kilograms of mass of that. And so I'm wanting to know how much of this gets yielded. Now, I guess, and they're looking for kilograms. Okay, so over here, I'd be looking for mass. Okay, so let's do stoichiometry for that. Nothing's balanced, so maybe let's balance things. Why don't we put I'm seeing magnesium 3 there and just 1 here, so I'll put a 3 there. But now that gives me 6 hydroxides. And over here, if I write this as HOH, could I do that? Maybe. I would need 6 of those. So that gives me the 6 hydroxides. It also gives me 6 hydrogens. Whoops. 6 hydrogens. So over here, if I put a 2 there, that's going to give me the 6 hydrogens. But it also gives me 2 nitrogens, which I have. So I think I'm balanced with that. Get rid of that. Don't need that. Okay, so it's balanced. So let's do our stoichiometry. So we're going to go from a solid to moles to another, back to a solid. So step number 1 is to take mass of Mg3N2 and convert it to moles of Mg3N2. So moles are equal to mass over molar mass. The mass is 24.5 kilograms divided by, the molar mass of magnesium nitride. I've got to figure that out somewhere. Magnesium is 2431, I think, times 3. So that would be 3, 9, 12, 7. And then 2 nitrogens. And nitrogen is 1401. So 2 of those would be 2802. So altogether it'd be a 5, a 9, a 10, 1, 100.95. 100.95 grams per mole. So then the moles will be, calculator, it's got to be 0.25-ish, 0.2 something. Okay, decimals right there. 24.5 divide 100.95. Okay, I'm getting 0.2526. Oh, now here the grams cancel out, but not the kilo. So this would be kilomoles. That just means 1,000 moles, right? Okay, so that's step 1 done. Let's do moles to moles then. So I want to take the moles of magnesium nitride and convert them to moles of ammonia. So it looks like it's a 1 to 2 game. So I need to double things. So I write down what I have, 0.2526 kilomoles of the magnesium nitride times, 1 mole of magnesium nitride gives me 2 moles of ammonia. So I need to double that number times 2. So now I'm getting 0.5052 kilomoles of ammonia. Okay, next step, or last for stoic, let me do it in white, will be to take the moles of ammonia and convert them to mass of ammonia. So my formula will be mass is equal to moles times molar mass. Moles, 0.5052 kilomoles times the molar mass of ammonia. Okay, nitrogen's that, hydrogen is, 3 of them would be this, so 1704 times 1704 grams per mole. So I'll take that number that I just got and times it by 17.04. So I got 8.6086. 8.6086. And the moles cancel out, but the kilo won't, so that'll be kilograms. Okay, so that's theoretically how many kilograms of ammonia I would get. But I know that the process is 81% efficient. So this is my theoretical or stoichiometry value. So I'm going to put it down here, 8.6086. And then up at the top, I don't know experimentally, or when I actually do the experiment, what it'll be, times 100. Okay, so now to solve for x, I'm going to multiply both sides by this and then divide by 100. Okay, so take that number and times it by 81. Okay, and then I'll divide by 100. 6.97. So x is equal to 6.9729, etc. Looks like they want 2 sig figs, so I'm looking at their answers up there. Did I write that right? Yeah. And I'm not seeing one that's close to mine. This one's probably closest, 6.7. Maybe I got the molar mass of something messed up. At any rate, this is how you would do the question. You'd first find the stoichiometric value, and that's my theoretical number. That'll go on the bottom there. And if it's 81% yield, 81 goes over there, and you're solving for that.